Worried about robots taking over the world? Don't be. This one doesn't have a brain. Picture a robot that walks, hops, and swims, but has no brain, no computer, and not even a single sensor. It might sound like a scene from a sci-fi film, but scientists in Amsterdam have made it real. This tangle of soft plastic tubes, powered by nothing more than flowing air, turns into one of the fastest soft robots around. As the air rushes through its legs, something strange happens. The legs fall into sync. The robot starts to move with surprising coordination, adapting effortlessly to obstacles and even switching from walking to swimming without being told what to do. No code, no circuits, just physics. And it's got researchers rethinking what robots really need to be intelligent. I've been speaking with Alberto Comoreto from Amolf University, and while this sounds like the stuff of the future, its inspiration was fantastically simple.
The origin of all of this comes from a day where I was working on another project where I needed to take a tube. You can imagine a small version of the gardening hose. My goal was to have a tube that when you bend it, it creates a kink and blocks water to go through. But this tube, because of some mechanical reasons that we didn't understand at first, it started to oscillate on its own and it started to really move around at very high frequency, almost as if it has some sort of activity to it. It felt very strange. So then we slow it down with a very fast high speed camera. Then we realized the movement that the tube is going through is a very interesting movement, and it looks like an animal leg, like even human legs when we walk around we actually do the same, a very similar motion to this tube.
Can you explain in simple terms how does it work?
I think the first layer is the tube itself. And the way the tube enters this motion, I think is the first important layer to understand. And then when you put multiple legs together, that's the second layer. Now, when the tube bends, because I'm giving air or water or any kind of fluid in input to this tube. So I'm really providing water. For example, you can imagine opening the tap of your gardening tube. Well, because water is coming in, then pressure inside the tube will go high because the tube is bent. But because pressure goes high, the point at which it's kinked, so it's deformed, that point will move on the tube itself. So it will spontaneously roll away from where it was because of this pressure going up. But now, because of this phenomenon, eventually later pressure will go down. Because of this very delicate interplay between pressure going up and down and the shape of the tube, you really have a two-way influence. And this results in the tube oscillating.
So the oscillation is caused by the difference in pressure, and that forces the movement in the tubes so that they walk along like an animal. What could we use this for?
For now, legs of robots are typically rigid, bars, metallic. Sometimes they are soft, but they are for sure not tubes. So the first challenge is how to make this tube more ready for the real world out there. And in few decades ahead, we imagine that because we removed electronics, then you can imagine very tiny robots that can carry important drugs that need to be delivered inside your body and at some specific locations. Then you can imagine these tiny robots that move around your body and find their way autonomously and deliver the drugs that you need. And because there is no electronics or no microelectronics, then these robots could be extremely safe and not harmful at all because they are just mechanical, small, little creatures that could dissolve in your body later.
So you'd say that there is an advantage in simplicity in design.
That's a very good point because we also think that's an important aspect we want to highlight. In our case, we work with tubes, but you can imagine the similar principle, fundamental principles, more high level, could be applied to other kind of very simple mechanisms. You can go small in your body in a safe way, but also you can imagine space applications where there is very often solar bursts that would destroy completely maybe your electronics. And in these very harsh environments, there is an advantage in having simple, robust, and reliable machines that still, move around as if they had a very complex computer with them.
Would you think that this robot would help with the people that are scared that the robots are going to take over? This one doesn't have a brain.
That's a very good point. And I have another example that could help also in emphasizing what we mean by simplicity, right? In our research group, there is another project going on building an artificial heart that should replace malfunctioning heart in your body. Imagine if your heart wants to adapt to your need for oxygen and it has to synchronize with the rest of your body, right? Then principles that now implemented in these walking robots, you can imagine them being implemented maybe in such a device. And this would be a fully mechanical, very reliable system that doesn't need the software update. Because if I have an artificial heart in my body and a software update comes, I would be a bit skeptical in updating my heart.